Hello there and welcome back. Before we dive into the world of strings, it's important to know that, unlike other types we've discussed so far like int, float, char, etc., a string is actually a class with many useful methods. In the upcoming lectures, we'll explore the string class and its methods in detail. However, before we start that journey, it's important to provide a brief explanation of what class and its instance objects are. With this foundation, we'll be ready to start working with strings. Alright, in C#, a class is a data structure that combines properties, methods, etc. into a single unit. But what does that exactly mean? Let's explore this concept with an example. Suppose we're building an application for a football club and we need to structure its players' information. So we can create a class called player and define the information we need to know about the player, such as their name and jersey number. Here's an example of what the player class might look like in C#. This example demonstrates the structure of the player class. It consists of two properties, name of type string and jersey number of type int. Additionally, there is a method named running, which displays a message indicating that the player is running. With this single structure for the club's players, we can easily register as many players as we need. For example, we can create a new instance of the player class and assign it to the variable player1 to store and access its information. Next, we assign John to the name property and 7 to the jersey number property. Okay. As you can see, by declaring a variable of type player and using the new keyword with the player class, we create an instance or object of the player class and store its information in the player1 variable. To illustrate how we can use the player class to perform tasks related to players, we invoke the running method on the player1 object to output a message indicating that John is running. Alright, as mentioned earlier, we can register as many players as needed using this class in our application. For example, let's say we want to add another player named Diego. Okay, for better understanding, if we run these codes in VS Code, we'll see these messages in the terminal. These examples show how we can create multiple instances of the player class to represent different players with their own information and perform specific tasks for each player individually. As you may have noticed, a class serves as a blueprint or template for creating objects. In the current scenario, player1 and player2 are instances of the player class. This means that they were created using the blueprint provided by the player class. Okay, the running method we defined in the player class is an instance method, which means that all instances created from this class have the ability to invoke this method individually. However, if we add the static keyword while defining a method, we can create a static method. Here's an example. As you may recall from previous lectures, this is how we can define a static method. In this example, we've added a static method called jumping to the player class. This method outputs a message indicating that the player is jumping. Since the jumping method is static, instances of the player class such as player1 and player2 will not be able to invoke this method or any other static methods of this class. To invoke the jumping method, we use the name of the class directly. By calling it on the class itself rather than on an instance of the class, we can access and utilize these static methods. As you noticed, the main difference between a static method and an instance method is that a static method belongs to the class itself, whereas an instance method is specific to each individual instance of the class. Alright, up until now, we've primarily focused on static methods when working with various data types. These include methods like int.parse, float.parse, char.parse, etc. It's important to understand that these methods are all static in nature. This means they are called directly on the type itself rather than on an instance of the type. In our upcoming lectures, we'll explore string methods that encompass both instance methods and static methods. To get you ready for instance methods, let's jump into VS Code and provide an example of an int instance method. As you can see, we've declared a variable of type int to store a number. In this case, the age is an instance or object of type int. To convert this number into a string, we can use the toString method. So let's say string age equals age dot toString. Next, let's display the result in the terminal. Save the file and give it a try. As expected, we can observe that the string age is displayed in the terminal. This example indicates that the toString method is an instance method, as it's invoked by an instance of type int. However, if we attempt to invoke this method directly using just the int type itself, the compiler would issue an error indicating that only an instance or object of int type can invoke this method. It's important to mention that we haven't covered keywords such as public, void, etc. yet. But don't worry, we'll explore classes and these keywords in detail in the intermediate course. Excellent! In the next lecture, our attention will be on the string type. Looking forward to having you there.